y. Now that you have changed the origin of your data set, essentially what you do is this point represents the average of x's. So if you have different amount of x's, so you have this value of x, 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 so you have different values of x over the x-axis, right? What you do is you take the average of all those x's and you mark x bar over here. So you mark x bar, that is the average rainfall for the past 50 years. That is the average annual rainfall for the past 50 years of India, the data among the data that you have collected. Similarly, you find out the average agricultural output for India for the past 50 years from the data that you have collected, and you get some y bar. So essentially there was a agricultural output like this, there was an agricultural output like this, there was an agricultural output like this, and you take up the average of all of these values and you find a y bar. And then you draw a horizontal axis across y bar and a vertical axis across x bar. What that does is it shifts this data, the origin of the data set to the point x bar comma y bar. So this point essentially is x bar comma y bar. That is simple to understand. So we have the shifted origin to x bar comma y bar. Now what happens is the value of these all these points change. Essentially all these points represented positive value, right? All of these points were positive with respect to this origin. But when we talk about this origin, these points are actually in the third quadrant. So this is the first quadrant, this is the second quadrant, this is the third quadrant. So this quadrant that I'm talking about, this is the third quadrant, and this is the fourth quadrant, right? So essentially what happens is these values, they turn out to be in the first quadrant. These values, there are two values which turn out to be in the second quadrant. There are about 1, 2, 3, 4, 5 values which turn out to be in the third quadrant, and about 3 values turn out to be in the fourth quadrant. Now what happens is, as you can see, since I had predicted that there will be a positive relationship between rainfall and agricultural output, since positive relationship means I can expect a straight line like this, there are more values in the first quadrant and in the third quadrant. There are hardly any values in the second quadrant and fourth quadrant. So most values are found in the first quadrant and in the third quadrant. Now what is the characteristic of the first quadrant and the third quadrant? So let me just change the color once. So in the first quadrant, x bar, or rather x dashed, since I have changed the axis, x dashed is positive and y dashed is also positive. Now if I multiply a positive number into a positive number, what do I get? I get a positive number, right? So I get a positive into positive. If I multiply the x values with the y values for the points in this plane, suppose this point, this gives me a positive, this gives me a positive value in terms of this axis, x dashed, and this gives me a positive value of y axis in terms of this axis, so a positive value of y dashed. If I multiply those two values, so if I multiply x into y, I'll get a positive number, right? Because all of these numbers are positive with respect to this new axis. Similarly, if I look at a point here, this point gives me a negative x-axis. With respect to this axis, it gives me a negative value because this number is negative. Again, if I look at this y value, will again be negative because with respect to the y dashed axis, this value is again negative. So again, in the third quadrant, we can see that we are multiplying a negative number with a negative number, which actually gives me a positive number. So we multiplied a positive number with a positive number, that is, we multiplied a positive x with a positive y to get positive, and in the third quadrant we multiplied negative x with negative y to again get a positive number. What happens is, if we look at the entire data, so let me just think about it now mathematically. Suppose we have a lot of data, so we have x1, y1, that is, suppose if I talk about 20 years for example, or if I talk about 22 years since it's 2022 right now, suppose this represents the average annual rainfall and the agricultural output for the year 2000, then or maybe 2001. Then we have x2, y2, which is the average annual rainfall and the agricultural output for the year 2002, so on and so forth, and we have a lot of data. What we do is we define a new variable. Suppose we define a new variable and we call that x1 minus x bar, that is one variable, and the other is y1 minus y bar, right? So basically we change the origin of the scale. That is, we are shifting all of these data set with respect to this origin. Initially the origin was here, now the origin is here. And essentially we develop a new data set, Z dashed or maybe Z. Now what happens is we essentially talk about another variable, and x1 minus x bar into y1 minus y bar gives me a new variable. So what I do is I multiply all of these. So I have x1 minus x bar into yi minus y bar. Then I have x2 minus x bar. So I have x2 minus x bar and y2 minus y bar. So I'll have different values, right? If I have 20 values of x1, y1, x2, y2, I'll have 20 values of z. Similarly, I'll have 20 values of these product terms. Since most of the values lie in the first, for the positive relationship that I've considered, since most of the values lie in the first quadrant and in the third quadrant, most of these values will be positive. Again, most of these values. So if I add up all of these values, if I add up the 20 values, I'll end up with a pretty positive number, right? Right. So I'll end up with a positive number, and what this positive number signifies is that most of my values are located in the first and the third quadrant. Had it been in the reverse way, had I have data, suppose I had a data which was like this. Suppose I had a data like this, looking at the orange data set. These data, they would have given me a negative relationship. Why? Because in the second quadrant, x values are negative, whereas y values are positive. So their product would be negative. Similarly, if I look at the second for the fourth quadrant, my x values are positive, whereas my y dashed values are negative. So if I multiply them, they'll again give me a negative number. So most of the negative numbers would be in my data set. All of these numbers would be negative. There would be very few positive numbers, and their sum would again be negative because most of the numbers are negative. So the way in which you find this value, summation, basically what you get is, so if I write that down in short, it would give you something like I equal to 1 to n. Suppose you have n data sets, you would have xi minus x bar into yi minus y bar, something like that, and that would essentially give you some idea about how your data behaves, whether it's in the positive relationship type or whether it's a negative relationship type. So this is essentially the beginning point of the correlation analysis. Now there are certain developments which we'll be developing in our further videos. This is basically the main concept of correlation analysis.